In this example, we have the first fraction, 7x over 4x squared minus 9, minus the second fraction, 5 over 4x squared plus 12x plus 9. So this particular example, we're going to be subtracting versus the last two examples we added. Over here, we're going to subtract the two rational expressions. Alright, so let's factor out the denominators in both fractions. Now, what I notice in the denominator of the first fraction is it's a difference of square because the first term and the last term are both perfect square. So therefore, our factors are 2x minus 3 and 2x plus 3. And then put my minus here. Now for the second fraction, when I factor, I also notice that this denominator is another perfect square, just like the last example. So our factors will be 2x plus 3 times 2x plus 3. Now you can still factor the usual way with the x table, and you'll end up with the same factors. But again, this is the factors for the second fraction's denominator. Now let's identify our LCD. So if we look at our first fraction, we have a factor of 2x minus 3 and another factor of 2x plus 3. Now in comparison to the second fraction, I have already one 2x plus 3, but there's another one, so I'm going to include it, the second factor from the second fraction, 2x plus 3. So here is my LCD, 2x minus 3, 2x plus 3, and then another 2x plus 3. So here's the denominator from the second fraction, and here's the denominator from the first fraction. And again, just to review, I only wrote 2x plus 3 two times because that's how much at most it's repeating in the second fraction. There's two factors of 2x plus 3, so therefore in my LCD there's 2x plus 3. Not 3. Again, don't write the total. If you do that, you're just going to end up doing extra work, unnecessary work, which is unneeded for it. You don't want to go through that process. Alright, once you finish identifying your LCD, let's get common denominator for both fractions. So let me rewrite the first fraction. So 2x minus 3, and then 2x plus 3. So the only thing I'm missing in comparison to my LCD is the extra 2x plus 3. So I'm going to multiply the numerator and denominator by our missing factor, which is the 2x plus 3. Now we're going to work with the second fraction. So let me put my minus first. And then let me rewrite the second fraction. So 2x plus 3. And then another 2x plus 3. So in comparison to the LCD, I have the 2x plus 3 and the other 2x plus 3. The only one I'm missing is the 2x minus 3. So I'm going to multiply the numerator and denominator by 2x minus 3. So when I multiply, I'm going to have common denominator. I'm going to leave it in factor form. So now I'm just basically going to combine as one fraction so that I can combine the numerators. So the first part is the 7x times 2x plus 3 close parenthesis, and then minus the second part, which is the 5 times 2x minus 3, over my common denominator, which is the LCD. So I'm writing the LCD for the work. Alright, now I'm going to simplify this side. So it says 7x times 2x plus 3. So I'm distributing the 7x. What I'm going to have is 14x squared. And then I'm going to distribute the 7x to the plus 3, which is going to be plus 21x. Now, next is the minus 5. So minus 5 to the 2x, because I'm distributing to the 2x minus 3. When I distribute the minus 5 to the 2x, it's going to be minus 10x. Then I'm going to distribute the minus 5 to the minus 3, which will be plus 15 over my LCD. So now in the numerator, I'm going to combine like terms. So the only thing I can combine is the 21x and the minus 10x. So what I'm going to have left is 14x squared plus 11x plus 15. And then I'm just going to write my LCD in its true form. So 2x minus 3 times 2x plus 3 times another 2x plus 3. So there's nothing in common between the numerator and the denominator, meaning I cannot simplify this fraction. So this is my final answer. And again, you're just going to leave the denominator in factor form. Now when you're writing out the answer, just be very careful since we have a long LCD and then we also have a long numerator. Just be very careful. Don't want to write small mistakes or make small mistakes and end up getting the wrong answer. So be very careful with that. But what I do stress is be very careful when you're working with subtraction. Basically, the minus will go to the 5, and I'm distributing, instead of just 5, now it's negative 5 to the 2x and the negative 5 to the minus 3. So when I distribute the minus 5 to the 2x, that's how I got minus 10x. And then when I distribute the minus 5 to the minus 3, that's how I got plus 15. So again, be extra careful when you're working with subtraction of rational expressions.